Hi everyone, and welcome to another video for Agricultural Engineering 311. So in the end of the previous video I gave you a bunch of formulas, and I said in the next video we'll start using them. So this is the formulas that was on the PowerPoint slide, and what we are basically doing is you have calculated how much water your plants need and how much your system can deliver. Now you need to figure out if that is how much water the plants need and the rate at which I can deliver a certain amount of water. Then I need to figure out how long will it take me to give that amount of water to the crop or the plants. So firstly, you can see at the top, and I'll share this example with you on SunLearn, but you can see at the top there's a lot of information given to you: the soil water capacity, emitter spacing, effective root depth, application efficiency, emitter delivery, lateral spacing, wetted emitter radius, and the plant water requirement per day. So the first question usually in this kind of calculation is to determine the available soil reservoir. So what that means is you want to determine how much space is in the soil for the water to fill up the soil. So you'll take the wetted surface, and the wetted surface is the radius multiplied by the lateral spacing. So just to show this on a sketch, so maybe this is your main line and these are your laterals, and you have got a bunch of emitters. So that radius that is used by the emitter multiplied by 2, so you've got both sides, and then multiplied by this lateral spacing. So it will be the radius 1,6 multiplied by 2, then divided by your lateral spacing, which is 5,5. Okay, then that multiplied by your effective root depth, and that you get from the top is 0,7 meters, and that multiplied by your soil water capacity, and you can see that at the top that is 110 millimeters per meter, so 110. And if you've used all of this, then the answer you will get for number 1, your available soil reservoir is 44,80 millimeters. Okay, the next question is gross application, maximum gross application. So how much should you apply in order for your system with its evaporation losses? How much should you apply to the soil for the amount that's needed to end up in the soil? And that is your available water reservoir, so that's what you calculated in number 1, divided by your application efficiency. So that's at 44,80 millimeters divided by 0,85, and that will give you 52,71 millimeters. So that's how much you should apply. Okay, then number 3, the standing time. So how long is it going to take you to apply this amount of water? So if you look at the top area, this area, you'll see something that's very important is your emitter delivery. So this thing will tell you there how much water will your system be able to deliver per hour, and that's 45 liters per hour. And then you've got your lateral spacing as well as your emitter spacing. So that will be, if this is your main line, that'll be how far are your laterals spaced, as well as how far are these emitters spaced. In other words, your lateral spacing and emitter spacing will basically give you the whole area for your crop. So to calculate how long you require, it's the amount that you have to apply, which is this 52.71 millimeters, divided by the rate at which you can apply your water, 45 liters per hour, divided by the area, which is 5.5 multiplied by 2.8, and that will give you 18.038, which when you convert it over to hours is 18 hours and 2 minutes and 16 seconds. So the last one, number 4, the theoretical cycle length. So this is calculated by using that last value, your plant water requirement per day, by using this one. And this says the water requirement is 7 millimeters per day. So then if your plant requires 7 millimeters per day, and your available water reservoir is 4.80 millimeters, then taking that and dividing it by those 7 millimeters per day will give you 6.4 days. And that is how you calculate these calculations. I'll be leaving for you another example in the on Sunlearn.